What's poppin', dogs? Mr. Allen here with some graphing of trigonometric functions. The first one here is y equals -5 cosine of 2 theta plus pi plus 2 on the outside of that cosine function. So when I look at something like this, first thing I want to do is I want to factor what's inside of that cosine function, right? Otherwise, we will get our phase shift incorrect, all right? So what I'm going to do here is I'm going to factor out a 2 from theta and from pi. You might be like, but a pi doesn't have a 2 to give. You got to do it anyways. Here's how it works. We got y equals -5 cosine of 2. Then we got another set of parentheses, theta. And then if I divide it out 2, I'm going to show that by doing pi divided by 2. I just divided by 2. And if you didn't quite follow that, you can also look at it like this, okay? I'm going to scooch this down just a little bit. If I were to distribute this 2 back in, I'd get 2 theta, which is that, and 2 times pi over 2 is just pi. Okay, so always double check yourself before you wreck yourself that you did it correctly, okay? And by doing so, you can distribute back in to figure that all out, all right? So now I'm ready to rock and roll and put down some information. My amplitude here is 5. We'll deal with the negative here in a moment when we're graphing, but the amplitude's still 5. What about my period? Well, my period is normally 2 pi. So if I divide by 2, this is the period multiplier right here, it'll give me my period. So we get pi. Cool. So how am I going to use that? Well, my scale, we'll say, of the theta axis, if you will, is going to be that pi divided by 4, because there's like 4 really distinct chunks of a sine or cosine graph, right? So we'll divide it by 4, and then my scale is just pi over 4, right? That doesn't simplify. So we're going to go by pi over 4s. We're going to have to make some adjustments on the graph here, all right? Now my midline is the plus 2 out there, so y equals 2. And my phase shift, which I can now correctly identify, is going to be pi over 2. So we're going to go left, pi over 2. Cool. All right. Let's do it. So let's get my ruler in here. We're going to put that at y equals 2 for my midline. Cool. Good dash line. Boom. And then, let's see here, we got, so cosine normally starts above the midline, but because it's negative, now we're going to deal with the negative, it's below the midline. So I'm going to be 5 below the midline, but I'm also going to the left pi over 2. So we're going to be, instead of 5 below the midline right here, I'm going to be 5 below the midline right there. All right, so we're going to take that guy off. And actually, I'll do this in a different color here. Boom. 5 below the midline, left, pi over 2. So that's my start point of this cosine function. So my next one needs to be on the midline. But how far are we moving? We're moving by pi over 4. So I'm going to add a pi over 4 right here. We'll call this negative pi over 4. Then we have 0. Then we have pi over 4. Oops, pi over 4 right here. And then we'd have pi over 2. And then we'd have 3 pi over 4, 3 pi over 2, so on and so forth. But I think we can get everything we need right in this little range here. So then oops, not right there. I'm at the midline, boom. Then I'm going to be 5 above the midline. So way the heck up here. Then I'll be back to the midline, and then 5 below the midline when we're at pi over 2. And now I have all of my points that I need, and I can graph this thing. It's going to be kind of steep and squished together. Let's see if we can make it still look decently curvy. Woo. I really have to concentrate. There we go. Boom. We have ourselves a cosine function of y equals -5 cosine of 2 times, in parentheses, theta plus pi over 2, close, plus 2. Boom, there we go, awesome. And if your teacher wanted more, you could also always, pop all these in here. I'm just gonna do it for fun here. Maybe I'll speed this up, maybe I won't, I don't know what I'm gonna do. But there we go, boom, boom, whoop. And then over here, we're back to the midline, then above, then back to it, then below. Oh my goodness, this is hyperspeed. Hopefully I don't screw this up. And let's see here. I'm going to go with really zigzagging through there. Boom, there we go. That's not that bad. All right, so all those other ones are still part of that cosine function. You're generally just asked to do like 1 period or maybe 2 periods of the graph. Just make sure you read those directions and do what your teacher tells you to do, because they're the ones grading your test, not me, unless I'm your teacher. I don't know. All right, let's do uno mas example in this video, and then we'll call it a day. All right, so we got our second example here, y equals 6 sine of pi over 2, in parentheses, right, it's already factored actually for us, which is nice because we can see our phase shift, theta minus 1, and then close, plus 1. All right, so what's my amplitude here? It's 6. How about my period? Interesting. We have pi over 2 here. So I have to take 2 pi and divide it by pi over 2, aka multiply it by its reciprocal. So really it's 2 pi times 2 over pi. Cancel the pi's, I got 2 times 2, that's 4. My period is 4. All right, you might notice also on the graph, I took off the scaling because of this, all right? So my period's 4, which means my scale, I'm gonna go by 4 divided by, goes into 4 chunks, 4, which is 1. So my scaling along that theta, I'm gonna do 1, 2, 3, and 4. That 2's a little ugly there. That's a little better. And then we got -1, -2, -3, and -4. So there's my scale, right? It's kind of weird. We're used to seeing pi's and things like that, but the pi cancel out, and we're just going by regular old numbers. All right, now my midline, that's gonna be y equals +1, so shifting up 1, and then my phase shift, well, it's -1, which means I'll go to the right 1. Okay, so now let's put our midline down. We have y equals 1 here. Nice little dash line. And then we'll go ahead and start graphing, all right? So for sine, it normally starts on the midline, but I am shifting to the right 1, so on the midline at 1 will be right there, okay? Now the next one, I would be going above the midline, because it's +6, and I'm gonna go 6 above the midline, which puts me way the heck up there. And then I'll be back to the midline. Then I'm gonna go below the midline for my next point, which would be right about here, I think. Yeah, 1, 2, 3, 4, 5, yep, I'm 6 away. And then the last one, I'll actually just go right to the edge of the graph here, which would be at +5. We can even mark that right here. Boom. And now I have a full sine period here. Let's see if I can get this nice. I'm gonna go backwards with it. Then I can see where my pen's going. Oh. Got a little squiggly right in here. But we're all right. Okay, we survived. As long as you're trying, as long as you got some decent curves, I think your teacher will be very, very happy with you, okay? It's if you're doing stuff like this, I'll show you in a sec here. Let me get the rest of these points here. The points that you don't necessarily have to do. But if you're like, not cool, bro. But I'm gonna dash these in now. Cool. And one thing to note, this little guy right here, when you're at the ends like that, you should show it curving back up to the midline, or if you're at the very top, curving back down to the midline. It's super duper important. You will lose points if it's like just shooting down, and it should be coming back up, all right? A little pro tip right there. Otherwise, you guys, I hope you enjoyed the graphing of trigonometric functions. I enjoy it, so hopefully you did as well, and you like the video, and have a wonderful, fantastic day.